Now, with this session, we're going to look at some factoring of trinomials. These are some that appear on your worksheet. Not going to do them all, just give you some techniques and go through some examples. So let's go through, okay? Something of this sort, we know it's a minus at the end, therefore it can only be a plus and a minus. So you say, well, what can that factor to? You got to go through the process of setting up possible factors. Check, check, check. Inner 2, negative 4a, outer 2, positive 9a, a positive 5a overall. We're good. Go to another problem, okay? Again, same kind of rationale there. This is more involved because we have the leadoff coefficient other than the 1. Whenever you have that, the very first thing you need to look for is a common factor. There are none, so we've got to go through the trial and error method. We have the other option that was shown to you on another presentation about the multiplying the n terms, turning it into a more algorithmic approach. Whatever you're comfortable with, here it is, it's factored. And anytime you do a trial and error, check the inner 2, 15x, the outer 2, negative 8x, combined 7x. We're good. Couple more, okay? Again, you have to play around factors here of both 9 and 16. So, but we have a positive at the end. So whenever there's a positive at the end, both terms take the middle sign. So we'll go through and trial and error on that one. Play with both factors, 9 and 16. And we are going to get it, and here it is, factored. Again, check 6x on the inner 2, 24x on the outer 2, 30x overall. We're good, okay? Keep on at it, all right? This is called a quadratic trinomial. So you see what happens is when you multiply that, when you factor that, it turns into just one binomial squared. That's called a perfect square trinomial, okay, which factors into a binomial squared. All right, you recognize that because the first term is a perfect square, the last term is this perfect square, and the middle term is twice the product of the two. And that's how you identify the perfect square trinomial. That pattern, if we go back and try it this way, we'll recognize that pattern right here. A squared plus 2ab plus b squared is a perfect square trinomial factoring into a binomial square. And if you recognize that, good. It's that much less work you have to go through, okay? Again, it's practice, it's trial and error with a lot of these. Always look for a common factor, nothing you go there. Again, it's going to be a trial and error. The only thing I can command this is the factor. It needs to go through an algorithm of trial and error on its own just to find the combination. But again, always check inner 2, negative 5y, outer 2, 36y with a negative 5y is 31y overall. We're good. Okay. Hey, make your life easier. Pull out the common factor of 6, then this becomes easy to factor, okay? Pull out the common factor of 6. Look for that wherever possible. Make your life easier. Makes the factoring of this much easier than as if that were 6 up front, okay? And then again, you set up the stage for factoring it, check it, you're done, okay? All right, look at this one. Pull out the common factor, which is 3x. It leaves you with a simpler problem to factor from there. Pull out the common factor, 3m, right? Okay, no common factor there, so you just got to sweat through it. All right, continuing on, get some more examples going here. These should not be that problematic, okay? You should be able to do these. This is, of course, we're going to identify a common factor. Then we're going to identify the difference of squares right there. A squared minus b squared. Got it, okay? All right. The fact that this is x to the 4th and x squared, what's that mean? Well, first off, we got a 2 that we could pull out. And then this is going to factor with an x squared term and an x squared term, okay? So here we go. Setting the stage, there it is. Of course, factored now, check it, okay? It could have been a difference of squares had that been a perfect square number, but it is terminated at that point, okay? Hopefully they won't be too problematic for you. Here's one, okay? What not to do. Don't go and expand this, okay? Because then you're making life more difficult. Then you have to distribute. The idea is to factor. So I'm going back. I'm going to undo that. I'm going to tag this. I'm going to say, gee, I wish that were looking like something else. Well, then we do the substitution. We simply say, let that x minus 1 equal u, and for some reason this reordered to terms, no big deal. Okay, I'm not the right option. Okay, I put it back in, the typical order, descending exponents. Okay, you're seeing this. U is now x minus 1. You're doing it by hand. Little sidebar calculation over here. U equals x minus 1. Factor that in terms of u. Okay. All right. Again, factor. Done? No, you're not done. You need to remember what u was. You need to return the value of x minus 1 for u. There you go. Then you're going to simplify your terms. Obviously, the 1s are going to cancel out here. You're going to distribute the 2, go through all that algebra, and lo and behold, you end up getting, bottom line, one more step. There it is. Who would have guessed? That now is factored, and factored completely, okay? Common factor, look for common factors. This is with x and y, so you have to have x and y in the factor. No common factor, just got to sweat it out, check it, and be done with it. Move on. Don't labor the point, okay? Okay, you need to practice with these. Again, you can opt to do my option of multiplying the n's, or you can just sweat it through. At least you know in this case, n sign positive, both take the middle sign, so that's a positive and positive there, factor, okay? No big deal, you don't like that? Turn it into substitution. So now you can deal with that. One look at that and you should have that factored, right? X minus 8, x plus 2. Well, I'm sorry, u minus 8, u plus 2, okay? But of course, it is not in terms of u, so replace, go back. Now, if you could have jumped from there to there directly, fine. You just have another option going with this substitution. Okay? Same thing there. All right? A little bit more cumbersome because the terms, but not impossible. Again, you have to play around here with a lot of different factors. Factors of 63. You're probably guessing 9 and 7. That might be your best shot. And factors of 4. It's a trial and error approach, okay? So we'll see what it produces. 9 and 7 was the combination that seemed to go. All right, check. Negative 18xy, negative 8xy, negative 28xy, combining for negative 46. We're good, okay? Keep at it. Okay, large numbers, don't let them scare you, okay? You can certainly deal with them. All right, this is going to have to factor with an x squared and a y in the binomial groupings, okay? Just don't forget that. Don't discount that there's a y there. A y and a 3y, because there's a y in the original problem. All right? Well, that does it for this session. So, practice the